Imagine building something meant to last longer than human civilization itself. The pyramids of Giza have stood for about 4,500 years. Now picture a project designed to endure for 100,000 years, 20 times longer. This isn't science fiction, it's happening right now, in Sweden. They're building a deep geological tomb for one of the most dangerous materials ever created, high-level radioactive waste. The goal? To keep deadly nuclear fuel safely locked away for 100 millennia. Scientists estimate that's how long it takes for spent nuclear fuel to become as harmless as the natural uranium it came from. This isn't just about storage. It's about isolation, placing the waste so far out of reach that no future event or civilization can stumble upon it. The challenge is immense, but the responsibility is even greater. Nuclear power has provided clean energy for decades, but it leaves behind a legacy of radioactive waste that remains hazardous for millennia. Most of this waste sits in temporary storage, requiring constant monitoring and security, a temporary patch on a permanent problem. Sweden is aiming for a real, permanent solution. Let's journey deep beneath Sweden's forests and coastlines to explore a project that blends cutting-edge science with profound ethical duty. This is the story of the Forsmark Repository, a project to solve a problem for a future we can barely imagine. It's about science, responsibility, and how we're trying to be good ancestors. It's a testament to human ingenuity, facing up to the consequences of our own discoveries. The world is watching because this affects all of us. What does it take to build a promise that lasts 100,000 years? Let's find out. What exactly are we trying to bury? When nuclear fuel is used, it becomes spent fuel, still intensely radioactive and dangerously hot. This material emits radiation that can cause severe illness, death, and environmental damage lasting centuries. The real problem is its longevity. Some elements decay quickly, but others, like plutonium-239, have half-lives of over 24,000 years. To be safe, the waste must go through many half-lives, hence the 100,000-year timescale. Most spent fuel is stored temporarily at power plants, first in water pools, then in massive steel and concrete dry casks. These are robust for decades, maybe a century, but they're not a walk-away solution. They require constant security and monitoring. What if society collapses or knowledge is lost? Future generations could inherit thousands of dangerous containers scattered and unmanaged. This is the ticking clock scientists are racing to stop. The global consensus, the only truly safe long-term solution, is deep geological disposal, burying the waste so far down it's permanently removed from the human environment. Anything less is just passing the problem forward. That's why Sweden is digging deep. Enter Forsmark on Sweden's eastern coast, a site chosen after decades of searching for stable, ancient rock. Forsmark's geology is key undisturbed granite, likely to remain stable for hundreds of thousands of years. The plan, a network of tunnels 500 meters below ground, shielded by solid granite. This is a modern-day pyramid built downward for concealment, not display. Forsmark is watched by the world. Its success could set the standard for nuclear waste disposal everywhere. Before construction, SKB built the ASPO Hard Rock Laboratory to test every detail underground. Scientists spent decades perfecting drilling, studying water movement, and refining sealing methods. This isn't rushed. It's a slow, methodical, science-driven process. Every detail must be right when you're planning for 100,000 years. The world is waiting to see if Sweden's solution works. The stakes couldn't be higher. How do you keep something safe for 100,000 years? Sweden's answer, the KBS-3 method, a multi-barrier system like Russian nesting dolls. The waste itself is a solid ceramic, resistant to dissolving in water. The first barrier, a cast iron canister encased in corrosion-resistant copper. Each canister is 5 meters long, weighing 25 tons. Copper was chosen for its stability in oxygen-free environments. The second barrier, bentonite clay, which swells when wet, forming a dense, impermeable shield. The clay protects the canister from rock movement and blocks groundwater. The final barrier, 1.9 billion-year-old granite bedrock, chosen for its stability and low permeability. At 500 meters deep, groundwater moves slowly and has low oxygen, preserving the canisters. Once filled, tunnels are sealed with concrete, leaving ancient rock as the ultimate guardian. Even if one barrier fails, others remain. It's redundancy by design, protection for millennia. Forsmark isn't just an engineering feat, it's a social experiment in trust. Building a nuclear waste repository requires public support, not just scientific approval. Sweden's approach: decades of consultation, transparency, and community engagement. Site selection was voluntary. Local communities could opt in or out. 2 communities, including Forsmark's Osthammer, agreed to participate and conducted independent reviews. Residents had real power and a voice in the process. Transparency was key. All research and safety data were public, and experts held open meetings to answer tough questions. Honesty about risks built credibility and trust. After years of debate, Osthammer's council voted overwhelmingly in favor. Jobs and investment helped, but trust was the foundation. The Swedish model shows that treating people as partners, not obstacles, can achieve consensus on even the toughest issues. It's a lesson in democracy and science communication. When people are empowered, even the most daunting projects become possible. That's the Swedish way. Even with decades of research, a 100,000-year project has critics and uncertainties. The main concern: will the copper canisters really last? Some scientists warn that SKB's models may underestimate corrosion risks, especially from sulfur in groundwater. If a canister fails, the bentonite clay must contain the leak. But critics argue this weakens the safety case. There's also the challenge of predicting geology over millennia. Ice ages, shifting rock, and groundwater changes add uncertainty. Regulatory bodies take these concerns seriously, requiring ongoing research and staged construction. The first canisters won't be sealed forever until confidence is even higher. This is a bet on our understanding of chemistry, geology, and time. The debate is ongoing, and the system will adapt as new knowledge emerges. No one claims absolute certainty, but the process is designed to learn and improve. That's how science moves forward, even on a million-year timescale. The debate over Forsmark is essential. Environmental groups argue we shouldn't proceed until all uncertainties, especially about copper corrosion, are resolved. They advocate for continued surface storage, where waste can be monitored and retrieved if needed. Their principal precaution: once buried, waste is nearly impossible to recover if something goes wrong centuries from now. On the other side, SKB and the Swedish government stand by decades of research supporting the KBS3 method. They argue that risks are manageable, and even in worst-case scenarios, the multi-barrier system prevents significant leaks. They warn that indefinite surface storage is risky, costly, and unfair to future generations. A deep repository is a passive safety system, no human intervention needed. It's about taking responsibility now, not passing the burden forward. The debate is healthy, but the need for a permanent solution is urgent. Sweden is choosing to act. Forsmark's importance goes far beyond Sweden. Over 400 nuclear reactors worldwide produce high-level waste, most of it in temporary storage. The world is watching Sweden and Finland to see if deep geological disposal is viable and acceptable. If Forsmark succeeds, it could be a blueprint for other nations, scientifically and socially. The KBS3 method and Sweden's transparent, community-driven process could break political gridlock elsewhere. A proven solution could also change the conversation about nuclear energy's future. If we solve the waste problem, nuclear power becomes a more acceptable tool against climate change. But the stakes are high. A failure would set back global efforts for decades. Sweden's scientists aren't just building a vault, they're shaping the world's nuclear legacy. The outcome here could influence energy choices for generations. Forsmark is more than an engineering project. It's a statement about who we are and what we owe the future. We benefited from nuclear power. Now we take responsibility for its legacy. This is an act of intergenerational stewardship, choosing not to pass the problem on. The repository is a message in a bottle to a future we'll never see. We understood the risks, and we acted. Its safety doesn't depend on warning signs or records, but on physics, chemistry, and robust design. Forsmark forces us to think on a timescale beyond our own lives, connecting us to the slow processes of the Earth. Our actions today will ripple through time for longer than we can imagine. The journey isn't over. Debate and research will continue. But building Forsmark is a monumental step forward, a symbol of hope and responsibility. It shows that with science and ethical duty, we can tackle even the most daunting challenges. This is our promise to the future. We tried to clean up our room before we left. That's a legacy worth building. And it starts deep underground in Sweden.